10.5 notes, polar form of complex numbers, page 2. So a whole lot of words on this page. We just graphed complex numbers on a Cartesian-like grid instead of a horizontal x and a vertical y. We had a horizontal real axis and a vertical imaginary axis, which means that when we take a complex number, we can do what we did earlier in this chapter and rewrite it in terms of its polar form or trig form. Sometimes you'll see this referred to as a trigonometric form of a complex number. This text uses polar form. I believe the review for the final, because that was from a couple of years or semesters ago, may still say trigonometric form. Know that those both mean the same thing. We exclude z equals 0 because then we're at that point 0, 0, and there's not really a theta there. So we are going to use these definitions for non-zero complex numbers. And you know what? They are going to look just like they did when we were working with x and y. Here, that real part, the horizontal, our A, is r cosine theta. The vertical part, the imaginary part, that B, r sine theta. Which means that if we start with a complex number written this way, A plus BI, we end up with r cosine theta being substituted in for A, r sine theta being substituted in for B. We get z equals r cosine theta plus ri sine theta. In this version here, we factored the r out. Sometimes you'll see it written this way, r cis theta cosine I sine. Just shorthand because mathematicians don't really want to write out that whole cosine theta plus I sine theta part. Okay, we know that we can use, just like with the xy coordinates, we can find r. So up here on our triangle, this is our A, this is our B. We can use those to find r, square root of a squared plus b squared. This should look familiar. You may see it written like this with the absolute value bars. It's called the modulus, or sometimes you'll see it as the absolute value. What is the absolute value of z? Keep in mind when we talked about absolute value before, absolute value was the distance from 0. We looked at a horizontal distance when we defined absolute value of numbers. Here we've got a point on the plane. That absolute value, or the modulus, is still the distance away from 0. So where are we? We've got another one. Z equals the absolute value, or the modulus of z. That's just r times cosine theta plus I sine theta. You very rarely see it that way. Remember that the angle theta, that's called the argument. Sometimes you'll see it identified that way, the argument of z, and we can always find the angle by setting up that tangent relationship. If theta is the angle that's made with the x-axis, then the tangent of theta is going to be opposite over adjacent, or b over a, when we're talking about a complex number in a plus bi form. So example 2 down here, you're asked to find the absolute value, or the modulus. Modulus. And that's the square root of a squared plus b squared, in this case 4 plus 12, square root of 16 is 4. So the absolute value of z here is 4. Z is -9, and we can plug this into the formula. One thing I do want to point out, think about what this looks like. If here's my axes, -9 is right here. If I'm looking at distance from 0, that's a straight line distance along an axis. It's just 9. Okay, we could plug that into the formula. We get -9 quantity squared plus 0 squared. -9 squared is 81, and the square root of that is 9. Same thing here on C, sorry. Z is 12i, which just means it's right here somewhere. There's 12i. And so the distance from 0, the modulus, is just 12.